Let's talk about reflection. The vocabulary for Module 15C will be learning about reflection, the angle of incidence, the angle of reflection, and the law of reflection. When sound waves encounter an obstacle, some of the sound waves bounce off the obstacle and go in another direction. This is the action we learned about in the last module that we call an echo. Some of the sound will actually travel through the obstacle. And under the right conditions, the same thing happens to light waves. This is the action we refer to as reflection. In experiment 15.2, we see a demonstration, and if you haven't read that, pause now and read the experiment, that the angles of the light ray reflected were perpendicular to each other and equaled each other. The light ray reflected from the flashlight made with a perpendicular line is called the angle of incidence. So incidence means beginning. The reflected light ray made with a perpendicular line is called the angle of reflection. This brings us to the law of reflection, a physical principle. The angle of reflection equals the angle of incidence. So in the experiment, we will actually be using a compass to determine the angles that are reflected, and we'll see that they equal each other if the experiment comes out correctly. The law of reflection is responsible for how mirrors work. Light reflects off of an object and up toward the eye. The pattern of reflected light is read by your eye and is converted to electrical impulses which are sent to the brain. Take a look at the figure 15 from your text. We see this lady and she's looking into the mirror. The brain converts the electrical impulses into an image. To see things, light must be present. Eyes cannot send any signals to your brain unless light reflects off of the object being observed and then enters your eye. After observing the reflection, the message can then be sent to your brain to form an image. What this woman is seeing is her foot. Why does the woman looking into the mirror see her foot? Well, the light reflects off of her foot, hits the mirror, reflects off of the mirror, and enters her eyes. When this happens, the woman's brain will think that the light travels in a straight line. Her brain extends the light backward, or the path of the dotted line, and this makes the woman's brain think the image of her foot is actually behind the mirror because it thinks that the light hitting her eyes is coming from the start of the dotted line. This is the process of images forming in the mirror. So let's look at that. The image comes from the woman's foot and goes to the mirror. It's reflected off of the mirror to her eye. At this point, she actually sees her foot, and it appears to be behind the mirror. But it's not a true image. The light reflects off a mirror. It's detected by her eyes. The brain receives the electrical impulses and extends the light backward. So that's this dotted line to form an image behind the mirror. But the true image is actually over here on the left. This is a false image on the right. As a result, the fact that the brain interprets light as traveling, let me try that again. As a result, the brain interprets light as traveling in a straight line. So she looks, when we're looking in a mirror, we think we're looking in a straight line. But at some point, what we're seeing is a reflection. We're actually seeing an image reflected back at us. So we aren't looking at a straight line. And when we do the experiment, you'll be able to see that interesting concept. So, if you have any questions, be sure to contact me. We'll be moving on to 15D in the next video, and we'll talk to you soon.